Alright guys, today we're going to talk about graphing systems of equations. So a system of equations is when we have two or more equations with the same variables. Okay, the solution, so the answer, is the point or points that they have in common. So points that make both of them true. So when we're graphing these, if I graph these two, so if I graph this line first, I'll use black. So remember, we use our y-intercept, which is -4. So I'm going to start at the -4 on my y-intercept. Okay, and then use the slope. So rise over run. So up 2 to the right 3. There's my other point. Okay. Then if I go right 2 up, or up 2, right 3 again. Okay. Now I'm going to go ahead and graph this other equation in red. So if I graph this other one in red, I'm going to start at +7. Right there. And then I'm going to go, remember this is -3 over 1. So I'm going to go down 3. Right 1, down 3 to the right 1. I'm going to do a couple of these points. Down 3 to the right 1, okay? And I'm going to go ahead and draw in my lines. Okay. So use black to draw on the other one. Okay. I use a couple of points because it's going to help me actually graph to make sure that I'm getting all the points correct. Now, when I want the solution is the point at which they intersect, or the point that they have in common. So this point is at the point 3, -2. So that is the solution, would be 3, -2 would be my solution. Okay? So since it only crosses once, it has one solution. And that solution is 3, -2. So now I'm going to go ahead and graph these two equations. Okay? So that's an absolute value, so that's going to make that v. So I'm going to go to the left 3, down 2, and I'm going to go ahead and make this v right here. Draw my dots. Okay. And draw my v in there. Draw the v there. Okay. Now I'm going to go ahead and graph the line, which is the second equation. So I'm going to start at +1. I'm going to go down 1 to the right 4. You already noticed they already have an intersection point. I'll go up 1 and to the left 4. But if you notice, I do see where they're intersecting. Okay, but I'm also going to go up 1 to the left 4 one more time. And I notice that it actually crosses this V, or this black graph, twice. Okay, so this one actually has two solutions. The first one is 1, 2, 3, 4, 5, 6, 7, 8. So -8, then up 3. That's the first solution. The second solution is the point 0, +1. So sometimes you can have one solution or two solutions. It just depends on what kind of graphs we have. And those are my two solutions, -8, 3 and 0, 1. Okay, for these ones, I'm just going to go ahead and graph these two equations. I'm going to graph the first one. We'll do the first one in blue. Okay, and to save some time, I'm just going to go ahead and put my dot at +1 for my y-intercept, and then do down 1 to the right 2. Okay, and I'm going to go ahead and do that for a few points, so hold on one second. Okay, there's my first line. Okay, you might want to pause it and jot that down. And now here's my second line. Okay, I'm going to start at -3, and I'm going to go do that same slope, down 1 over 2. Okay, I go ahead and graph that. If you want to pause it and graph it, you can. Now, if we notice, these lines will never intersect. Those are actually parallel lines, and if we look at our slopes, okay, look, our slopes are the same. Okay, so they're parallel lines, so they'll never cross. So this actually is a no solution. Okay, let's look at the next example. Okay, let's go ahead and graph these. Well, I'm going to go graph the first one, which is going to start at -1. Okay, and then go up 2 to the right 1. Okay, and then when I graph this line, I'm going to, okay, there's my line that I just graphed. So I graphed this first one. Okay, so there's the first one I graphed. Now if I graph this second one, and maybe I'll use red for this one. If you notice, it's the exact same line. If I start at -1, I'm going to go up 2 over 1, up 2 over 1. It's the exact same line. Okay, so if I drew this line in there, they just overlap. So there's not one solution. They overlap multiple or infinite amount of times. So this would actually be infinite solutions for my answer. So remember just how many times points they have in common. That is the number of solutions. Okay? And then just wherever it crosses or wherever they intersect, that's what the solution is. And you can have no solutions and infinite solutions, or you can have a point or multiple points. Okay guys, I'm going to go ahead and graph this first one, which is starting at 4. We're going to go up 2 over 5. Okay, then I'm going to go ahead and make my line. All right, you can go ahead and pause it and make that line as well. Now we're going to go ahead and do this absolute value. Okay, remember I'm going to multiply all my values by 2, so it'll stretch my graph out. But then I'm also going to shift to the right. So I'm going to go to the right 2, and then my point should end up looking like this. If you need to make your table, you can pause it and make your table and then shift them all to the right 2. But it's going to end up looking something like this. Okay, so I'm going to go ahead and draw my lines. And I kind of noticed that I have points that already intersect, okay, which is what we want. Okay, there's my V. So my solution, so when I want a solution, it's these 2 points right here where they intersect. Okay, so the first one is at 0, 1, 2, 3, 4, so 0, 4. Okay, so at the point, the XY point 0, 4. The second one's at 5, then up 1, 2, 3, 4, 5, 6. So 5, 6. So those are my 2 solutions. So just wherever it crosses, it's the solution. Or where it makes both of these equations right here true. That's what a solution is making both of those true. Okay, so I'm going to go ahead and graph this first one. I'll use black to graph this first one. So I'm going to go down 4, make my dot, and then do my slope, which is negative 2 over 7. So I'm going to go ahead and go down 2 to the right 7. And I'm going to make my line. Okay, now I'm going to go ahead and do the second graph. Okay, now I can't actually graph that one yet. I need to get it into slope-intercept form. So I'm going to subtract 2x from both sides. And I have 7y equals negative 2x plus 56. Okay, now I'm going to go ahead and divide both sides by 7. Or everything by 7. So I have y equals negative 2/7 x plus 8. All right, now I'm going to go ahead and graph this. If I go up 8, and I'm going to do that slope, negative 2/7, which is right there. Okay, now I'm going to make my line. And some of you guys might have noticed something. Once I make this line, okay, once I make this line, that's bad. I noticed that those 2 lines are parallel, and some of you guys might have noticed these slopes were the same. So since I have the same slopes, I know they're parallel. Since they're parallel, this solution is going to be no solution, since they're never going to cross. All right, so what is a solution of a system of equations? We kind of talked about this, but a solution of a system of equations is the point that makes both of the equations true. You can have one point or multiple points, but it's wherever makes both of those equations true. It also is the intersection point of your 2 graphs. So wherever those 2 graphs cross, that's the solution, that point. It could have multiple points, it could be 1, it could be no points, or it could be infinite points. All right, go ahead and try your practice problems.